Welcome to a lesson with Dr. Powell. You may have noticed as we were doing this that we don't necessarily have to write out that limit. Maybe you're tired of writing it out. Let's take a look at maybe how we could think about that a little bit. What if we had 2 times x to the 11th minus 3 times cosine x plus 4 times sine x. If we want to take the derivative of this, you notice how we when we factored the 2 out of that limit portion that dealt with this, we basically just get 2 times the derivative of x to the 11th. We just can write it down like that. What about over here? When we do a limit, we're going to be able to factor out that -3 out of this portion and just get the derivative of cosine, which is negative sine. Now, what about over here? We can factor the 4 out of the corresponding portion and just get the derivative of sine, which is cosine. So proceeding, we end up just getting 22x to the 10th plus 3 sine x plus 4 cosine x. Kind of handy. Maybe another way of thinking about it is when you multiply a function by 2, you're stretching it by 2. So it's like you're taking, in fact, the slope, if you think about, because you're only stretching in the y direction, so the run would stay the same, but the rise, it actually doubles the same amount as the stretch. And so the change of y has become 2 times the old change of y. So you really have 2 times the change of y over change of x in some sense. So it's like 2 times the slope. In other words, if you're multiplying by a constant, it just multiplies in the derivative. Now notice how you have addition and subtraction here. Well, in just regrouping in the limit, putting as we can with addition, because addition is commutative and we can replace things, and it's associative, meaning we can reorganize the parentheses, then it's completely possible to just, in the limit, just separate these different parts out and just take the limit of this, that, and then add them together. Thanks for watching.